All right, so shall we begin? Are you guys ready? Let's go. Okay, so before we even talk about what algebra is, I know some of you are going to be curious about what algebra is. So before we even talk about that, I'm going to talk about something called visual thinking. Okay, visual thinking meaning that we want to imagine the situation. Like there's a question in maths, there's a certain scenario. You want to be able to imagine what is happening visually with pictures, or you can either draw them or in your mind. Okay. That's before we actually get into what algebra is, okay? So today we're going to discover how visual models can actually make solving questions easy and enjoyable. All right. So it turns out that the lions also like ice creams. You know why? Because there were
Why?
only three of them and they ate 30 ice creams. That's a lot of ice creams, right? Sir, the shop bill says that 30 ice creams were eaten in total. So there were only three lions, and they actually ate 30 ice creams altogether. Okay, so now, how does this relate to algebra here? Okay, we're trying to actually find out how many ice creams did each lion eat? Okay, the shopkeeper also told us that each lion ate an equal number of ice creams. Okay, this is an important information that the shopkeeper told us. So look at this visual diagram here. Look at this picture. We've got a picture of a lion. So that's one lion, right? Then we've got another lion here and another lion. So we've got three lions in total, okay? And this picture actually tells us how many ice creams each lion ate. But we don't know the number, right? We only have a picture over here. So how many do you guys think? I want you guys to guess. How many ice creams do you think each lion ate? Perfect. So you're actually dividing by three. So the idea of division in mathematics is, let me remind you guys that whenever you do division in mathematics, it's equal division. Did all of you know that? Okay, and I'll repeat, anytime you're dividing in mathematics, you're actually dividing equally. So if I take 30 ice creams and I divide them equally and I divide them among three lions, I'm always dividing it equally. It's fair, it's even, okay? Every lion will get the same amount. So when I do 30 divided by 3, I'm actually getting 10. And you guys actually got that answer, right? If each lion ate an equal number of ice creams, then each lion actually ate 10 ice creams. Now, we're actually going to now talk about what algebra is. So this was something related to algebra. We'll actually come back to that example later when we introduce to you the concept of algebra and also the concept of visual drawing. Okay? So what do you guys think algebra is? I'm sure some of you have heard about this word before, algebra. Any idea what it is? So I'll tell you what algebra actually is. So algebra is basically a branch of mathematics where we use symbols. You might have seen something like X, Y, or Z in mathematics. And if you look at maybe your older brother or sister's textbook, you might have seen something like, why do we use those letters? Well, we use them to represent unknown values. Just now, remember how we used the picture of a lion? Because we didn't know how many ice creams each lion ate, right? So we use the picture of a lion. In algebra, instead of drawing that picture, we actually use symbols. But in this presentation today, we're mostly going to be using pictures instead, okay? Pictures and also the bar drawing, which I'm going to introduce to you guys now. Okay. Or after this one, where we'll talk about, okay, real life uses, just what are the real life uses of algebra? There's actually many real life uses, but you need to get the basics first. Some of the uses are figuring out how much money is remaining after shopping, the number of items in a box, or also, as we saw in the earlier example, how to actually split things equally, okay? Keyword equally. So those are some real life uses of algebra. Of course, algebra extends beyond the math class as well. We use algebra in coding games, in solving puzzles, and also planning events like birthday parties. All right, so the main topic, or one of the main topic of today is using model drawing in algebra, okay? That's the whole point, right? We're trying to visualize the information by actually drawing a model drawing. So let's see what kinds of model drawings that we have and how we can actually use them to help us solve questions. Okay, so first of all, okay, it turns invisible math ideas into pictures and drawings that you can actually see. So if you have a word problem, right? I know a lot of students, they don't like word problems. Word problems look very difficult. There's so many words, right? That's why they're called word problems. So the idea is that we're going to take all the information one by one from there. We're going to draw some models, okay? And from those models, we're going to be able to see visually and we're going to be able to understand what's actually happening and what the question actually wants from us, okay? And of course, like I said, word problems sometimes can be very lengthy. So it helps us to tackle complicated problems one step at a time. So we're going to draw one model one step at a time, and then that is actually going to help us to solve or break down the problem, okay? And of course, it is going to build confidence. This one I can guarantee if you practice model drawing, you will actually feel like a math superhero because later on, once you practice drawing enough, you won't even have to draw on a paper. You can draw in your mind. Trust me, this works. You're going to be able to draw these models in your mind, and you're going to be able to solve the question entirely in your mind. So that is how it's going to help build your confidence. Okay? So are you guys ready for some model drawings to see how it works?
Yeah.
Yes, okay. All right. So the first type of model drawing that we have is called the part whole model, okay? We're going to have one bar to represent the entire thing, the whole, and then we're going to have some models within that bar to show part of that bar, okay? So we're going to use that part whole model. That's the first type of model that we're going to use to represent the total as a sum of its parts, okay? So again, the words, you might not understand exactly what it is, but when we look at it visually, you'll be able to see what that means. Okay, so we have our first example for this kind of a drawing, which is this one. Okay, I'm going to read it for you guys here. We've got Frogsy the frog who lost 6 flies. Okay, so he had some flies at the start. Okay, Frogsy, and then he lost 6 flies. Okay, once he lost 6 flies, he now has 9 flies left. Okay, so the question is actually asking us, how many flies did he have originally, or how many did he have at the start? I want you guys to think about this. Okay, anyone, any idea? So he had some flies at the start, and then he lost 6 of them, but he still has 9 remaining. So how many do you think he had at the start? Anyone, before I show you the solution?
Do we have to plus?
Yeah, this is the problem, right? We are not sure if we have to plus or minus. Sometimes it's confusing, right?
Yes.
Hmm. So this actually model drawing is going to make us confident whether we have to plus or minus, okay? So let's see the solution here. By the way, you are actually right. We do have to plus, but why? Let's see why we have to plus it, okay? So we're going to draw one bar. Actually, this one is supposed to be one bar from all the way from the start to the end. And that is the whole. Do you guys know what whole means? Whole means the entire thing, right? Okay, whole means how many flies did Frogsy the frog have at the beginning? That is something we don't know. So we're going to draw one bar from here all the way to here to represent that. And then within that bar, we're going to make two groups, okay? The amount of flies that he lost and the amount of flies that he has remaining. So since the question told us that the frog lost 6 flies and then had 9 flies remaining, yes, to find out the total number, both of those boxes make the entire bar, right? Yes, exactly. We need to add. So we need to do 6 plus 9, okay? 6 plus 9 equals to 15. And from there, we understand that the total number of flies that Frogsy had was 15. Now, let's see how we can actually write that as an equation instead, okay? Remember, I mentioned that in algebra, we use symbols to write down unknown quantities. So in this case, the unknown quantity was actually the total number of flies, right? We didn't know how many flies that Frogsy had. So we say that let X be the total number of flies. And then because he lost 6, right? 6 of them, imagine that they fly away. So what happens when you lose something? You're supposed to minus it, remove it, right?
Minus.
Yes, so the flies have gone away. So from that total number, whatever that number was, 6 of them have gone away. And then how many are remaining?
9.
9 are remaining. So we can actually form this equation. This is called an algebraic equation where we have a symbol instead of a number. Okay. So we've got x minus 6 equals to 9. And we know, okay, what number when you minus away 6 gives you 9? That's what we just found, right? 6 plus
Yeah.
9, that gives us
15.
15. So
Yeah.
hence, x equals to 15.
15.
Okay, so we've got Tiger Tim here who spent some amount of money. How much? Well, he spent
$45.
$45. That's a lot of money on bubble tea. So he spent $45, but he still had some amount remaining. He didn't spend all of his money,
He
right?
had $30 left.
He had $30 left. So now the question wants us to draw a bar model for this. So I'm going to actually take this question over to my whiteboard and we're going to draw a bar model together. Okay?
Okay.
All right. Let me copy down the question here. Yes.
Yeah. Yeah. Yeah.
Okay. So we're going to draw one bar to represent the entire number or the entire amount that Tiger Tim had. Okay?
Can
So
we help, teacher? Can we help?
of course you can help. Of course. All right, so let's see. Like I said, we're going to draw one bar. So let me choose this one. Like a rectangle. Yeah, I'm making this into like a rectangle here.
Wait.
Okay.
You want
So
another rectangle?
which one?
Like this, you mean? Like this?
Yes. This one. This is like, okay. So this bar now represents what? What does it represent? That's important to identify.
$45.
No, so $45 is going to be the one inside the bar. So the first one that we draw, is going to
45.
be the total amount, right?
Yeah. 45 plus 30.
Actually, yes, it's going to be plus 30. So let's see. Okay, so if this bar, entire bar, represents the total amount that Tim the Tiger had, then we're going to actually make another one in here. Okay, let's see. This one. Okay, so I'm going to use this blue rectangle to represent how much money did he spend. Okay, so I'm going to do this. This is the amount of money that the tiger
He
spent,
spent.
right? That he
Yeah.
spent, yes. And then there's another part remaining, right? Okay, maybe I make this a little longer. There's another part remaining. That one is going to represent what?
$30 left.
Yes, or how much, yes, how much he has remaining, right? So this is what we call as the part whole model, okay? So I'm going to fill that one in with a red rectangle here. Okay, let me extend that. And there we go. There we go. So we've got this entire one, this entire bar over here. Let me show like this. This represents, okay, you're drawing it with me. That's awesome. All right, I'll give you some space to draw there actually with me. There we go. So yeah, go ahead. Okay, so tell me, what does this represent again? It represents how much? $45. So I'll write over here, this one is $45. And then I'll also write, what does it represent? Okay, it represents Tim spent, right?
Yeah.
This is the amount of money that Tim actually spent. And then what about the red one? Yes, that should be $30. And that actually represents what?
Me.
The remaining amount, right? So this one is going to be the remaining amount. That is, of course, $30. So what does the entire bar represent again?
45 plus 30. The total
Yes, but
number.
the total amount that he had, right? So this is the total amount. Or the total, yes, simply the total. So in order to find out the total, we're gonna have to do 45 plus 30.
Plus 30.
And how much does that give us?
For
Mhm.
75.
75. So Tim the Tiger had $75 in total at the beginning, right? That is what it means.
So 75 is the total money that Tim had.
That Tim had. Okay. So everyone okay with this example? You guys understand how it works?
Yeah. Yes. Yeah.
Okay. Anytime you get the final answer, you should always try and verify if the answer makes sense or not. Okay. So now that you know that X, or the amount that he had at the start, was actually $75, you're going to check if the story makes sense. So he spent $45, right? Okay. Okay, you're check. Okay, so because he had $75 and then he spent 45, So we're going to do 75 minus 45, right? Because now that money is gone. So we want to do 75 minus 45. This is to check the answer, okay? This is to check. So can you guys do this with me? Okay, come back here, guys. Yeah, that one is fine. So 75 minus 45. What does that give us? Okay.
Is
5
it
minus 5
is it
equals 7.
30?
Yes, and 7 minus 4 is equal to
30.
3. So we get 30, right? $30 remaining. Isn't that what the
Yeah.
question has also told us? Yes. So that means that our answer is actually correct. Okay, make sense, everyone?
Yes.
Yeah, it
All
does.
right. Okay, so now we're going to move on back onto our presentation. I'm going to clear the drawings now. All right. Thank you for participating. Let us come back here. So now we have actually solved this question by using the part-whole model. Now we're going to move on to the unit model. This one is also very, very important, okay? The unit model, what does it do? Okay, so we're going to introduce the unit model for problem solving involving equal groups, just like the one we had at the beginning, right? The lions and the ice creams example, something like that, okay? And then we're going to practice solving problems where the total is divided equally among some units, okay? Evenly among some units. Exactly as the ice cream problem, we had 30 ice creams. And then those 30 ice creams were equally divided among how many lions does anyone remember? How many lions
3
did we have at the
lions.
start? Yes,
3
three lions,
lions.
right? So those 3 lions, we're going to call them as 3 units, okay? So 3 units, we are dividing those 30 ice creams among those 3 units. So let's take a look at an example of this type of a unit model. All right, so we've got an example here. We've got 3 unicorns. So once again, just like we had 3 lions, now we have 3 unicorns. And then this time, they ate not 30 ice creams like before, but this time they're eating carrots, and they actually ate 60 carrots.
60.
Okay, so all 3 of them. Okay, the main thing here is that each unicorn ate an equal number of carrots. Okay, whenever we're
Yeah.
using these unit models, it has to be equally divided. All right. So if each unicorn ate an equal number of carrots, so how many carrots did each unicorn eat? Again, I'll let you guys take a guess first before I show you the solution. There we go. Yes, it should be 20. So once again, because the keyword here is that each unicorn ate an equal number, so we're going to divide, right?
Equal is
Yes, like I said in the beginning, right? Division is always equal in mathematics, okay? So let me share with you guys the solution here. So we're going to draw a bar to represent all the carrots, and then we're going to split it into 3 sections. Why 3 sections? Because there are 3
because
unicorns,
there's 3
right?
unicorns.
Yes, perfect. So each a little bar over here, each of these boxes, let's say, it represents how many carrots did one unicorn eat. So right now we didn't know this 20, right? So right now we don't know this 20. So, but what we do know is that the total number of carrots is 60. So we're going to represent this entire thing by 60. So that's 60 carrots. And then we have split it into 3 parts because there are 3 unicorns. So whenever we're splitting something equally, we're supposed to do division. So here we're going to do 1 unicorn gets 60 divided by 3, 3 units, right? So that comes out to be 20, as you guys are saying. So that means, now we can actually write down the equation. We can write it down like this. So 3 units or 3 unicorns, so 3u equals to 60. So look at this, we're using a symbol here, right? We're actually
Yeah.
using a letter. We're using the letter U to represent the unicorns,
Units
okay?
or the unicorns.
Or yeah, in general, we actually use it for units. That's correct. But in this case, okay, we can think of it as U
Unicorn.
representing, yeah, 1 unicorn, right? How much did 1 unicorn eat? So
20.
because here we have, yes, we need to do 60 divided by,
60
so let's do
divided
this
by
one,
3.
60 divided by 3, and that gives us
20.
20. It means that each unicorn ate exactly
20
20 carrots.
carrots.
And then once we find this answer later on, we can fill in these boxes. So this is 20, 20, and 20 because we want to confirm our answer, right? How can you make sure that your answer is correct? How do you make sure that the answer is right? You can check this one, right? This is 20, 20, and 20. So you do 20 times 3, right? Or you can do 20 plus 20 plus 20.
20 plus 20 plus 20 equals 60.
Correct. So repeated addition is the same thing as multiplication, right? So if I have so many times 20, I'll just times it, right? So 20
Yeah. Times
times
is the same.
3. Yes, and that gives us 60.
60.
So this is the same as in the question, meaning that we got our answer correct. Okay. So now let's take a look at another example. Without the solution, I will let you guys try it. Okay, another one involving the same kind. Okay, actually, we'll do this on our whiteboard. Okay, so this is another same type of example using a unit model. Okay, so let's read the question first. It says 5 robots used 100 volts. Do you guys know what volts is?
Is it electricity?
Yes, it's something to do with electricity, right? So how much volts? Volts is a unit. So how much volts are each or is each robot using? That is going to be our goal. But what we do know is 5 robots used 100 volts, and we're going to assume that each robot used an equal amount, okay? Yes, there we go. So we're supposed to do 100 divided by 5. Okay, but the question says draw a unit model, right? Remember, that is our objective for today. We're trying to draw a unit model. Okay, the answer is actually correct, but I'm going to show you how to actually draw a unit model for this. Okay? So once again, let me copy down this question to my whiteboard and we're going to draw a unit model for that. Okay? So the important thing is you always read the entire question, okay? I know sometimes it's very tempting to just see the numbers and quickly do the division or the addition, but we have to be careful, okay? We need to read the entire question. What exactly does the question want from us and so on, okay? All right, so let's take a look at this one. Okay, again, I'll clear the annotations here. All right, so we've got 5 robots that use 100 volts. Draw a unit model and write an equation to find the volts per robot, meaning how many volts did one robot use, okay? So I'm going to draw a model here. Again, I will let one of these represent the number of volts that each robot used. How many robots do we have?
5.
5. So I'm going to make 5 copies of this, okay? So I've already got 2 here. Let me go ahead and make 4 of them. So how many more do I need?
1 more.
1 more, right? So I've got this one. There we go. So now we've got 5 of these bars that make one entire bar, right? We've split them into, imagine that you've got one rectangle that you split into 5 parts, okay? Where each of those bars represents one robot. And because we know that the total number here, if I do this, how many volts did they use altogether?
100.
Yes, they used 100 volts, right? So I'll write over here 100 volts. Okay. So from here, what is our goal going to be? Okay. Okay, so you guys can just tell me for now on the mic. So since all of them, they used 100 volts, so we're going to actually write down 5. By the way, this is how I do this one. 5 robots. This is 5 robots. How many volts did they use? 100 volts. So 100 volts. So we are trying to find out what about one robot, right? One robot should be, okay, as you guys were saying earlier, since we have 100 volts, we're trying to equally divide them among the 5 robots. So we're going to do 100 divided by 5. What was the answer to 100 divided by 5?
20.
20, right? So yes, we get the answer as 20, meaning that each robot actually used 20 volts. So we can actually still write down, still 5 is not that many, so we can actually just write down the answer later over here. So each of these is actually representing 20 volts. Now, is our answer correct? Can you guys verify that?
Yes.
Okay, how do you verify it?
100. The way.
So how many
Plus
20s do we have
20
there? Yes, we're supposed to
times.
like plus to just to check, right? So we do 20 plus 20 plus 20. So we have so many times addition. So instead we can just
We
multiply.
can just times.
Yeah, so in order to check the answer,
25 times 20.
yes, 20 times 5 or 5 times 20. This is how you check if your answer is correct. And we know that 5 times 2 is 10. So we get another 0 here. Yes, we know that 100 volts is the total amount that all the robots use together. Okay, everyone with me now so far?
Yeah.
Everyone is okay?
Yes.
All good? All right. So that is on drawing the unit model. Okay, this one you will see it many, many times when you, as you grow up. Okay, you keep doing mathematics questions in higher grades, like year 6, 7, 8. You will still be able to apply this concept of a unit model. It's a very, very versatile one that we use all the time. Okay. All right. Okay, so let us come back here now. So that was an example on how to solve a question using unit model. Okay, so let's see what else we have. Okay, the last part is actually going to be on forming visual models or from visual models, moving on to actual abstract equations. Okay, we're going to bridge the gap from visual representations, the one that we just saw, moving over to actual algebra involving X, Y, etc. Okay. So I'm going to emphasize the progression from pictures to symbols and then finally on to equations, okay? Equation just means like a mathematical equation where we have an equal to sign. You can have something plus something equals to something. That is what we call as an equation. So, like I said, we'll come back to our very first example. Okay, the 3 lions that they ate ice creams, 30 ice creams altogether. So this is the very first one that we talked about, right? This is the visual representation that we gave. So we drew a lion and then another lion and another lion to represent 3 lions. And because that wastes a lot of time, right? We cannot draw a lion every single time you want to solve a question in the exam. Then you cannot do all the questions, right? So because of that, we can actually simplify it instead to like a box, something like 1 square, okay? So we can draw 3 squares and then we can say that all 3 of them added together equals to 30. Or if we want to make it even faster, okay, if we want to make it even faster, we can represent the number of ice creams that each lion ate with a symbol, such as L. Okay, we can do something like L plus L plus L equals to 30. Okay. And because you guys know that repeated addition is the same thing as multiplication, right? So we can actually write that as 3 times L. Remember, L just represents a number that we don't know yet, okay? We don't know what L is, that we don't know the number that L represents, so we're going to write that as a letter for now. So 3 times L equals to 30, and you guys were able to figure out earlier, remember, what should L be equal to here? So L should be 30 divided by 3, right? 30 ice creams divided by 3 lions. So L comes out to be, how much was it again? Please remind me.
And
10. So this is basically what algebra is. It's moving on from pictures. Suddenly now we're, well, not suddenly, but we're moving on from pictures to letters or symbols instead, just to make our working a little bit faster, okay? So it means that L, the number of ice creams that each lion had, was simply 10, okay? So far, what have we discussed? We've discussed the part whole model and we've discussed the unit model, and now we're actually moving on to algebra equations, right? Okay, so moving on. Now we can actually do some practice. Okay, you guys were you really wanted to do the annotation. I'll give you time to do some annotation on my screen. You can also do this on your own notebook. If you have a notebook or if you have your own whiteboard, okay, you can also do it on that. If you want to do it on my screen, I will let you guys do it, but one by one, okay? I'll let you guys do this one by one. So we're going to do some practice questions involving all three or the all the models that we just talked about. Okay, the first one was the part whole model. Still remember that? We have 1 bar representing the total, and then you split that 1 bar into 2 parts, where each part represents, it's not going to be equal parts, okay? One of them, okay, for example, we've got this question where a cat spent some amount, that is $20, and had $15 remaining. So we're going to draw a bar, 1 bar to represent the total amount that she started with. And then we're going to split that into 2 parts, where one of them represents how much did the cat spend, and the other part represents how much is remaining. So now I want you guys to raise your hand if you would like to draw the model on my screen, okay, on my whiteboard. Okay, so I'll let you guys do it one by one, okay? So right now, I'm going to let Yaja do this. So I'm going to copy this over to my whiteboard. I'll give you a chance to draw it, okay? Okay. So, all right, Yajat, now it is your turn to draw the model. Can you draw the model on my screen here? So draw one full bar to represent the total amount that the cat had. Are you able to annotate on my screen? 20. Yeah, so we have to add in this question. So you can see that once we draw the visual model, it makes it easier for us to understand whether we're supposed to subtract or we're supposed to actually do addition. Okay, well done, Yajat. So the answer here is actually $35. Always remember to give your units, okay? So $35 is actually what the cat started with. All right, so we've got another question on the same concept of a part whole model, okay? The whole is going to represent the entire thing, and then that's going to be split into some parts. Okay, any volunteers for this question?
Yeah, sure. A monkey had spent $50 and had $20 left. How much did he start with? It's plus.
Okay, but you need to draw the model. Can you actually do that for me? If I share if I share my whiteboard?
Okay.
All right, so I'm gonna share this on my whiteboard now.
Wait.
There we go. All right. So the amount that he spent, let's say you want to keep it on the left. Did he spend more or does he have more remaining? Xavier? All right, so now I can see that you've chosen the red one to represent how much did he spend. So can you write 50 over there? That is the amount that the monkey spent. There we go, perfect. And then the blue one represents how much he has remaining. That is $20, perfect. And now we're actually trying to find out how much did the monkey start with. So 50 plus 20. So we can show it like this. This entire thing over here from the start, this entire bar from the start to finish actually represents the total amount that the monkey started with. So 50 plus 20 equals to $70. Okay, let us move back over to our presentation here. All right, now it's actually time for you guys to form your own question, okay? Remember the pattern that we were talking about just now? Something spent some amount and then had some amount remaining, right? If you go back and look at the previous two questions, okay, so you guys are already going for it. Okay, so a what spent how much and had how much remaining? This is up to your own creativity. Okay, so I'm seeing here, okay, you guys are, okay, a dog spent how much? Let's see what you come up with here. I can see that Yajat is the one annotating here. Okay, $20. All right. Or $200. Okay. So the dog is very rich here. The dog spent $200. How much? Okay, Thachayan is doing. Okay, I like this a lot. All right, and had $100 left. So I want someone who hasn't tried yet. Okay, you guys are so fast with it. All right, I wanted to ask someone who hasn't tried yet, but that's okay. Like I said, you can raise your hand if you would like to attempt a question, okay? So here you guys have come up with a situation where a dog spent $200 on something and then had $100 remaining. So the dog didn't spend all of his money, right? He only spent $200. He had how much at the beginning? So then we do 200 plus 100 to give
100. You get
300.
300.
All right, good job. You guys are so good at this. So remember, these kinds of questions, you can also draw the bar model, okay? You draw the entire bar to represent the full money, and then you split it into two parts, one of them representing how much he spent, and the other one representing how much is left. Would you like to give this question a try?
Yeah, sure.
All right, can you read the question for me?
5 bears used 30 rolls of toilet paper equally. How many rolls of toilet paper did each bear use?
Okay, are you able to draw on your screen, on my screen here? Can you do that if I copy it to my whiteboard?
Yeah, maybe.
All right, sure. Give me a second then. I'm going to go ahead and copy this. And 5, finally. Okay, we've got all 5 of them now. And we want to imagine this one entire block as all 5 of the bears, right? And because the boxes are all equal, it means that all of them use the same amount. That's important, okay? Now, how many rolls of toilet paper did each bear use? Once again, we want to also write down the steps, right? So 5 bears, how much did they use? So 5 bears. We will say that they used how much?
30.
Yes, 30 rolls of toilet paper. Okay, Xavier, I'll get back to you in a second. Okay, 30 rolls. And then we want to write down how about, yes, perfect. So we draw it like this. We draw this 30 over here. So this is 30 rolls of toilet paper. So what about one bear, right? That is our objective. Our goal here is to find out how about one bear. So what is the operation that we need to do here, Lim? Perfect. So we do 30 divided by 5 equals to 6. So that is what we get. We get that each bear actually ended up using 6 rolls of toilet paper. And to check our answer, we can actually draw this on our diagram later. We can draw this 6, okay? Put 6 inside all of these boxes just to make sure that our answer is in fact correct. Does the sum of all of these give us 30? Yes, there's 5 boxes, so 6 times 5 does indeed give us 30, right? All right. Thank you so much for participating, Lim. Let us move on to the last bit before we actually end the session here. I'm going to summarize basically what we have learned so far, all right? Just a quick little summary. So initially, we talked about the part-whole model, remember? That helps us figure out what information is missing, such as the cat example, right? So there was a cat, she had a total amount of some money, which we didn't know. That was actually missing, right? But then from that information, we actually knew some other things. We knew how much he spent, and we knew how much was remaining. So we use that information with the help of this part-whole model in order to find out how much did she have at the beginning. So that was the first type of model that we learned about today. The second one, which I said that is really, really important that you'll keep using later on, right? That one is the unit model. So unit model, remember, they help us share or divide things equally. Anytime in maths you have a situation where something is being divided equally, you can always use the unit model or the unitary method, as we call it, to help you find out how much should each one person get. And then we also talked about how visual models actually translate into algebraic equations, right? Algebraic equations are the ones that use letters. So instead of writing something like where we had 4 kangaroos, right? So instead of writing 4 kangaroos, I actually simply use a letter instead. So I said 4K. And then I will say, instead of putting the arrow, I will say is equal to 120. Remember that question? Where all the kangaroos, 4 of them, they jumped 120 times, and we wanted to find out how many times did one kangaroo jump. So instead of doing all of the drawing, we can proceed. We can, from visual drawings, we can actually move on to algebraic equations, which will make our working a lot faster. Okay. So that is a recap on what we have done so far. And there we go. That concludes it. We have accomplished our mission. You guys are now able to use the power of visual math, okay? I want you guys to do a lot of practice, even when you're doing your own questions. Let's say your teacher gives you homework, okay? I want you guys to think about, how can I draw this visually? How am I able to actually visualize this or draw this such that I break down the question into manageable steps, okay? You draw them and then you visualize it. From there, you should be able to solve the questions. Okay, so if anyone is interested, okay, we also have a visual maths booster program to continue this journey that we started today, okay, of visualizing and solving questions. If you want to truly master these skills, you can always join our visual maths booster program. And with that, I think we will conclude the session.